in this video, we're looking at the learning target 4A. It says I can construct an expression. So really we're looking at this information and writing an expression for it. When it says expression, that means we're not going to come out with a final answer. We're just going to write out the expression that is modeling what this context here is saying. So I've got a a regular octagon has a side length of 3/4 x minus 1/4. So this is your octagon, and there's a side length right there. A regular hexagon has a side length of 12 minus x. So here's your hexagon, and there's 12 minus x. Write an expression for a perimeter of each shape. So we're going to do it unsimplified, and then we're going to simplify it down to its simplest terms. So if we know that it's a regular octagon, we know every side is the same exact distance. And so they are all 3/4 x minus 1/4. So there's a couple ways we could do this. We could do 3/4 x minus 1/4, and that we have 1, 2, 3, 4, 5, 6, 7, 8 of those sides. So that right there is an expression that is telling us the perimeter here. We could also write another one where it's saying, where we are writing out 3/4 x 8 times and minus 1/4 8 times. So that might look like this. 3/4 x plus 3/4 x plus 3/4 x. I'm just going to be writing this for just a minute here. 1, 2, 3, 4, 5. 7, 3/4 x right there. I think I've got 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's saying I have 8 of these 3/4 x. I also have 8 of the minus 1/4. So I've got minus 1/4, 2, 3, 4, 5, 6, 7, 8. So this and this are both in unsimplified terms right now. We're going to take either one of them and we're going to turn it into a simplified term. So what we could do is we could circle all of these and add up all of our parts, or we could distribute in our 8. So I'm going to do it using distributive property first. This is 8 times 3/4, and so what that looks like is, move it down here, 8 times 3/4. We can do 8 over 1, right, because 8 is 8 over 1. 8 times 3 is 24 over 4, and then we're going to simplify that down, and we're going to get the number 6x. Okay, that's one part, and then you would do 8 times 1/4, so that would look like 8 over 1 times 1/4, but it was a negative, so I'm going to make it a negative 1/4. 8 times negative 1 gives me negative 8 over 4, which gives me the number negative 2. That's our other part there. So if I were to combine this, I'm going to end up with 6x minus 2 as our final answer. That would be the simplified term, so that's what I'm looking for, is a simplified term of all of these side lengths added together. So then we could also just use that repeated addition, because remember, multiplication of 8 is just repeated addition 8 times. So I've got, if I'm adding together all of these, I already have them all with a common denominator of 4. And so then I'm just adding 3 plus 3 is 6, 9, 12, 15, 18, 21, 24, 24 fourths. See how these are exactly the same? So we're seeing that repeated addition is the same thing as that multiplication there. 24 fourths is going to be simplified down to 6, and remember they all have the x. So when we do the next part, we should end up with this situation as well here. So when we add these, they all have the common denominator of 4, and we're looking for what they are over. So it's 1 times 1 times, 1 plus 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 1 is 8. So it's negative 8 because they were all negatives. And that's where I came up with that, and you end up with negative 4 there. And so again, you would put those pieces together, and here would be your simplified version of the perimeter, because you add up all the sides to get the perimeter. Let's do that regular hexagon here. So it says 12 minus x. I've got another 12 minus x. I have that 6 times. So I'm just going to do this one with distributive property. And I'm going to be taking the 12 minus x. I'm going to be multiplying it 6 times. And so I'm going to say 6 times 12 is 72. And 6 times x is minus 6x. And that is the final answer for the hexagon. Right? So moving on to the on your own. So this one's a little bit different, but you're using the same idea of unsimplifying something and simplifying it. So thinking about how you can just write it out with all of its pieces and then combine all of its pieces.